In this question, we want to find the limit of x to the 1 over x power as x approaches infinity. So for the first step, as always, let's plug in infinity into the original equation and see what we get. We will get infinity to the 1 over infinity's power, which that gives us infinity to the zero's power. So in calculus, this is called an indeterminate form. So more calculation is needed in order to find the answer. Because we see exponential here, so one of the most common ways to solve is to rewrite the limit in a log form. First, let's set y is equal to x to the 1 over x power. Then we take natural log for both sides of the equation. We get ln of y is equal to ln of x to the 1 over x power. We have our natural log equation here. And so let's rewrite the right side as 1 over x can be put in front of the natural log. 1 over x times natural log of x. Okay, so now we have, let me just write the left and right side into one equation. We have the natural log of y is equal to 1 over x times the natural log of x. The reason we want to rewrite the equation in this form is because now what we want to find is the limit of ln of y as x approaches infinity. And that question becomes, we want to find the limit of 1 over x ln of x as x approaches infinity. So we have rewrite our exponential form into this natural log of x over x, a fraction form. And in the second step, you will see why this is easier to calculate. Okay, let me erase this. So our step 2, we need to apply L'Hopital's rule. So now we're calculating the limit of x goes to infinity, ln of x over x. So plug in x goes to infinity, what we'll get is infinity over infinity, which is another type of indeterminate form that can be solved by L'Hopital's rules. In this case, we want to take the derivative of both the denominator and the numerator, and we'll have the same limit value. And now we're calculating the limit as x goes to infinity of the derivative of top is 1 over x. The derivative of the bottom is 1. So that gives us the limit of 1 over x as x approaches infinity, which is 0. Okay, now you're done majority of this question. But 0 is not our answer yet. For step 3, we need to convert back to our original variables. So previously we've got the limit of x approaches infinity ln y is equal to the limit of ln x over x, and that gives us the answer of 0. So if we know the natural log of y approaches 0, that means our y must be approaching e to the 0's power. Therefore, we have the limit of y as x approaches infinity is equal to our original function, which is the limit of x to the 1 over x. And that's going to be equal to e to the 0's power. And that gives us 1, which is the answer for this question.